Hi there, I'm back again. So algebra and patterning. So we represented a growing pattern using differently colored tiles, well, drawing in this case, and we will now see how we can represent this growing pattern in a t-chart. It's a table of value. Okay, so first, term number, that's the easy bit because term number will be just 0, 1, 2, 3, 4, 5, 6, 7, and on and on. Okay, so total numbers of tiles. The total number of tiles for the first one times 0, that's 3. Now, actually 5. 1, 2, 3, 4, 5, 6, 7, 7. And of course, because it is growing by 2, you could also just add 2 each time you go up in a term number. So 9, 11, 13, 15, and 17, and so on and on. So what do you notice? If I'm looking at term number 0, that's saying 3, which indicates that yes, I have 1, 2, 3 red square tiles in that. And these, we talked about how these 3 red square tiles that actually appear no matter which term number that we are looking at, this is called the constant. So constant is present no matter where you look at. So it could be term number 121 and you still see these 3 red square tiles. So as you can see, if you look right over here, we can see that this is term 0. And term 0 tells you what the constant is. Constant times 0. So that is this one right over there. So how can I now represent how the number is going? So we talked about how it is going. It's going by 2 and it's called a multiplier or coefficient. So, okay, so 3 is going to be there because this is the constant. No matter which term number that we look at, 3 is always going to be there. And starting from term 0, as you go up in a term number, a pattern is growing by 2 because we are adding 2 circular blue tiles, 2 of those every single time. So this is plus 2, plus 2. And looking at the previous term number 1, when you go to term number 2, you will add 2 more. So keep on doing that. Bear with me, I will just have to keep on showing how the pattern is growing. 2 plus 2 plus 2, 2 more, almost there. And the last one, plus 2, and plus 2. So it is very cool because when you're using representing the pattern, the growing pattern using these drawings or tiles, you can see how the pattern is going this way. But if you see the table of value, the t-chart, you can see how it is going this way, that you are adding 2 each time to the previous total. Okay, so what do we see here? So if we look at, let's take a look at term number 6. And okay, you're starting with 3. This is the term number 6 that we're looking at. And I'm adding 1, 2, 3, 4, 5, 6. I'm adding 2 6 times. Adding 2 6 times. Okay, do you remember from previous years or previous grades when you are adding something repeatedly? What is that? So this is very key. Repetitive addition. Things like 3 plus 3 plus 3, 10 plus 10 plus 10 plus 10 plus 10, and all that. Repetitive addition is multiplication. This is key because if you're looking at grade 6, 7, and 8 math in Ontario, patterns are actually, you're looking at repeating patterns. So knowing that repetitive addition is multiplication, this is going to be super important. So going back to term number 6, so I am adding 2 6 times. So as multiplication, how can I represent that? So 3 is going to, constant is going to be always there. So 3, and you are adding 2 6 times. So 2 times 6. And let's just verify. 6 times 2, that's 12. 12 times 3, that's 15. Looking at the total number of tiles for term number 6, it is 15. Let's look at, let's say, term number 4. This one. So I have 3. Yep. 3 is going to be always there because it's a constant. And I'm adding 1, 2, 3, 4. I'm adding 2 4 times. So adding 2 4 times, 2 multiplied by 4. And this is 4 times 2. That's 8. 8 plus 3, that's 11. Yep, total number of tiles for term number 4, that's 11. So let's look at what we just did. What is that? I multiplied 2 by 4 for term number 4. I multiplied 2 by 6 for term number 6. Did you notice a pattern? Hey, I am multiplying 2 by the term number. So what if I actually, instead of representing term number by just saying term number, what if I decide, you know what, the changing number, the term number, it's changing. What if I say, you know what, I am going to represent this changing number as with using a letter and say n, and total number of tiles, I can say, you know what, I'm going to use a different letter. Let's say m. So how am I representing how many tiles that we have using these? So m, that's the total number of tiles. And remember, constant, you always at the end have to add the constant because it's always going to be there. But remember here, we multiplied 2 by the term number. We multiplied the 2 by the term number. And what if I am representing the term number using the letter n? 2 multiplied by the term number. And what do you have here? That is an algebraic expression representing this pattern. So you now have 3 different ways you're representing this pattern, which is quite amazing. And another way to look at it is, if we look at the actual pattern that I drew out, this algebraic expression, you can see it if we look at it closely. So 3 is there because that's something that you add at the end. But look at the 2. I have, when it is term number 1, I have one group of 2. One group of 2s. And when I'm looking at term number 2, I have 2 groups of 2s. Looking at term number 3, I have 1, 2, 3 groups of 2s. Looking at term number 4, I have, you see the pattern, right? 1, 2, 3, 4 groups of 2s. Term number 5, I have 1, 2, 3, 4, 5 group of 2s. And for term number 6, I have 1, 2, 3, 4, 5, 6. I have 6 groups of 2s. So if I wanted to find out how many blue circles that I have for term number 5, let's say I have 1, 2, 3, 4, 5 groups of 2s. So I would do 2 multiplied by 1, 2, 3, 4, 5. And that is exactly how it is represented right over here. So I will sign off for now and I'll be back. Thank you.